This podcast is brought to you by VinZero. VinZero pioneers solutions and services to the AEC and manufacturing industries to support net zero targets. Visit vinzero.com to learn more about how organisations design, build and solve through digitalisation. From VinZero to you, welcome to our Think Future podcast series. Each week we'll share conversations with industry leaders from around the world to find out how they're thinking future. Subscribe to VinZero Think Future for access to more episodes, interviews and profiles. Born and raised in Italy, architect Alessandro Ronfini worked on large commercial projects throughout Europe and the US before deciding to partner with Daniel Kidd and start Demo Architects. With a mix of technical expertise, construction experience and design backgrounds, Demo Architects works towards implementing high-tech and prefabricated solutions, both in commercial and residential projects, with a particular focus on sustainability and the principles of Passive House. We welcome to the program today, Alessandro.
Thank you very much for having me.
Alessandro, Demo Architects as a firm are focused on creating healthy, energy-efficient and design-focused environments with an emphasis on Passive House and net zero design. Can you help our listeners understand the key differences between Passive House and net zero-centric designs?
There's a lot of common points between Passive House and net zero. The main difference is that Passive House is a performance-driven standard and it's not necessarily tied to a net zero performance, while a net zero house needs to produce or generate or harvest rather in on-site all of the energy that it uses to heat and cool and run all the energy needs of a house.
So where did the term Passive House actually stem from?
Passive House comes from Germany. It's a standard that was originated in Germany. And the word house in Germany has a slightly different meaning than the one that it has in English. So it's a wider meaning. It doesn't only include houses in the American translation, but buildings in general. So a passive house is a house that does as little as possible to run. It's a house that is designed for maximum energy efficiency, but also for maximum comfort within the interior of the space. The term passive house is actually something that is a little bit controversial in the industry, depending on who you talk to, in the sense that it almost sounds like it limits the application to single-family houses. It's generally defined as a house. But the reality is that it's actually a standard that performs incredibly well at a larger scale. Multifamily buildings are really the buildings where it's the most efficient to use this standard because the added cost is limited compared to a single-family house, and the benefits are many and they spread out to a larger audience, larger public.
And you're certainly in a position to speak from experience. You recently completed your own Passive House project for your family. What was the key driver for you personally to embark on that journey?
Well, personally, I wanted to build a comfortable house. I wanted to build a house that had a really high quality interior air and a house that was, for me, inexpensive to maintain and easy to maintain. That also was, of course, another reason to build a passive house for me as an architect, was to showcase my technical and design abilities. I think that this house, it's not the only passive house that doesn't look like an energy efficient home, but it definitely stands out from the majority of passive houses in the sense that it's clearly design driven, but it's also the design follows the performance. So there's both aspects of it in the house. So it's a building that kind of wants to show that we can still do something nice and exciting even when we aim for this very strict standard.
So Alessandro, what are some of the key design elements for a passive home?
So the passive house highlights 5 key points to follow to create the passive house design. They are airtightness, thermal insulation, mechanical ventilation with heat recovery, high performance windows, and a thermal bridge-free construction. So the airtightness, the thermal insulation, they relate to the envelope of a building and to a certain extent also the high performance windows. So the idea is to create a very well insulated envelope that is airtight so that there's no loss of heat in any way from the interior of this building. Mechanical ventilation is a kind of a consequence in a way of this, because we have such a tight thermal envelope. We want to provide the fresh air through a system that is very efficient, that doesn't bring in cold air, but actually brings in preheated air and extracts the polluted air from the interior, and continuously provide that without the need of human intervention. And thermal bridge-free construction is also part of that thermal insulation. So we want to create a building that doesn't just have insulation in one detail, but it has insulation all over. So above, below, on the facades, at the penetration through the facade, every single detail needs to be looked at in order to create a building that doesn't waste energy and remains comfortable without those thermal bridges.
So can you just talk further through the key design elements there?
So for a passive house, for a successful passive house design, there's several components that need to be looked at. The first thing that generally is very important to look at is actually the siting and the location of a building. So of course, how we handle that, it all depends on where it is and the climate zone it's located. We work mostly in New York and surrounding areas, so we have a generally cold climate where the heating load is what is driving the design. So we try to do a building that shades itself or has some way of shading itself in the summer to avoid solar heat gain or excessive solar heat gain. But we also need to harvest as much sun as possible in the winter in order to have some of that heat inside the building. So designing the proper facades, the proper openings so that we can maximize the sun heating coefficient is something that's really important. Beside the design, the challenges are very technical for what concerns the construction of a passive house. So we need to look really at each wall and how they behave depending on the climate that the building is in. And the construction uses technologies that to a certain extent are relatively new, especially in the US market. We use membranes and tapes that have only been used in construction for a certain number of years. Most of these products are imported from Europe, but we're starting to see also some manufacturers in the US that start to look at these more advanced materials.
And I imagine that a passive house presents some challenges in the design phase with the complexity of some of those elements. What are some of the challenges?
The challenges are really in making all these components work together. So when we're working on a passive house, we need to always consider that as almost as a human body, where all the parts really need to work together. So it's really important to think about mechanical systems, to think about, again, the siting and the orientation of a building, and to think about how also the life of the building and how people will actually use that building. Is a family occupying a certain house going to cook every dinner on the stove, and do they need a certain type of ventilation because of that, or they order delivery all the time? There's a lot of variables in the construction of a house. There's a lot of things that can help adjust these little criteria, can actually help design a house that is efficient, not just as a whole, but also as for the people that are actually going to inhabit that and use it for the life of the building.
And you mentioned panelised systems. What are the benefits that panelised systems provide for this type of build, and why are they so essential?
We like to work with panelized systems for several reasons. Of course, it's not something we can do all the time, but if possible, we try to do that as much as possible. There are some cost benefits that are not necessarily related to the material themselves, but to the streamlined construction. So how fast the construction can proceed in the field with a panelized system. My house in upstate New York was built with a panelized system that actually didn't use any foam in its construction. So it was all dense packed cellulose, which is a 90% recycled material and very good insulation. And that system was made possible mostly because this was a prefabricated construction done in a shop. As a matter of fact, that insulation is very good, but at the same time is very prone to humidity, and to install it within the building envelope in a protected environment, in a workshop, in a conditioned workshop, is really the best way to deal with that, because if done in the field can lead to some problems. So that additional attention to detail, that control environment where a panelized system gets built, is something that really helps achieving the high performance as these houses tend to.
Are you looking for a digitalisation and net zero partner to help you achieve your goals? Join the thousands of AEC and manufacturing customers globally who have turned to VinZero to start their journey toward a net zero future. With 32 offices around the world, VinZero can connect you to the right technologies and workflow processes so you can maintain your competitive position and increase profitability. VinZero has an industry expert to help you navigate the best pathway forward wherever you are on your digitalisation and net zero journey. Visit vinzero.com to find out more. So are you finding generally from a design perspective that more and more of your customers are leaning towards having some of the construct of a building affected off-site rather than all of it on-site? And if so, why is that?
Yes, there's definitely more attention towards that. There's several reasons. Once again, one of the major costs is labor, of course, even more than materials. So to have a lot of laborers, especially if it's a suburban area where it's difficult to bring material, and on the other hand, if it's an urban area where it's very difficult to have the space to work with. So we try to use prefabricated component as much as possible. So try to move the construction of beams, of trusses, and of course of wall systems, especially outside of the site. That, as I said earlier, it has a cost implication, but it also reduces dramatically the amount of waste that is generated on site, and the one that's generated in the factory. In the factory, everything gets recycled and reused for other panels. On site, not a lot gets recycled as a reality, and everything generally tends to be dumped altogether. So, so to minimize the waste on a job site is something that is really, really good and that we're aiming for.
So from a sustainable perspective, we're also seeing a lot of conversation now around the use of mass timber. What role does that play in designs for demo architecture?
We're actually working on a project that uses mass timber in New York City. It's a very exciting material and with a lot of potential. And of course, it's been used for thousands of years before, so we haven't invented it. There's a lot of psychological good aspects of mass timber, the feeling of it, the aesthetics of it. It's a warm material. If you're a developer, it increases the value of a building. There are also health benefits in how it improves an environment. Again, mostly from a psychological point of view, but also if it's not treated, if we use low or no VOC stains and other coatings to protect it, remains exposed wood, and also again not a pollutant material. Well, one of the aspects that are most important, most regarded by the industry is the fact that unlike steel and concrete, it has a very low embodied carbon. So that means that it takes less energy to generate or to produce a structure made of mass timber than it does to actually have a structure made of concrete or of steel. And that's mostly because of the carbon sequestration throughout the life of the timber itself. This means we can do buildings that hopefully, if designed properly, consume less, but also that have less energy embodied in them.
And let's just unpack the benefits to passive house design as well.
One of the points that we like to highlight, even more than the sustainability aspect of it, than the energy efficiency that a passive house building achieves, is the fact that it has really extremely good consequence on the air quality and on the comfort of an interior environment. Because of its airtightness, in a passive house building protects the interior environment from pollutants, from pollens, from anything that might be bad, especially in an urban environment, from getting within the building. There is this filtering system through the ERV, through this mechanical ventilation. So all the air that is pulled through a fan inside the house in order to provide fresh air is always filtered so that again, none of these pollutants can enter in the house. And then the air that is extracted from the house, that's also constantly extracted, removes all the smells and all the chemicals that might be produced within the house because of, well, the humans and their interaction with the space. So this is a really good aspect, how it improves the air quality, how it improves the comfort of the interior of a building. For this reason, this standard is particularly good for people that have any sensitivities to the air quality. They have allergies, anything that can disturb them in the environment they normally live in. They'll find a much better and filtered and protective environment within a passive house. Because of all the added insulation and because of the airtightness, passive house building also particularly soundproofing. That means that there's no sound or very limited sound that can enter a building designed with this standard. Once again, this is something that is particularly useful if a passive house building is built in a city environment where we have plenty of noises on the street all the time. It really creates a healthy interior environment that is comforting, that is soothing, and that is extremely comfortable. And that doesn't apply only to residential space. There are office buildings, there are schools, there are all sorts of buildings that are built according to this standard. Finally, the benefit passive house is most famous for, which is of course something extremely valuable, is how much it reduces the cost and the operating cost of a building because of the very little energy that is needed to heat and cool and generally run and maintain a building built according to this standard.
And with these types of sustainable design principles, what role does technology play?
Technology is really helping a lot. Of course, pushing this technology forward. One of the most important thing that I can see is how energy modeling is becoming more and more easy to control, and therefore more and more popular and used by more and more architects and designers in the world. So energy modeling help us in the early stages of a project when we really are looking at the siting, at the number of openings, the mechanical systems, all the things that are really important for a building to work properly and to save energy in its life. So controlling that, and a lot of the new software makes that pretty easy for a lot of people without the need of extensive experience, is something that is definitely helping a lot. The data that we can extract from the buildings is also something very helpful. We are trying to harvest data and analyze data from the buildings that we are building. So, for example, in my house, I have ways of controlling both the indoor air quality, the energy consumption, and we always want to verify that what we have built matches the expectation and what we had estimated from the energy model. So it's important to use technology in this way.
And aside from passive house or net zero certified designs, how else are the principles of sustainability being reflected in architecture today?
There's a lot of talk about sustainability in the world, in the world of architecture. What I feel that is more and more understood by the general public is the need to consume less and to reduce waste. So more than plastering roofs with solar panels and just harvest the energy but continue to consume a lot of energy, I like to believe that more and more people are understanding that we need to consume less energy, that we need to reduce the waste. So we need to build in a smarter way, which again is not just trying to save our mistakes by generating or harvesting that additional energy, but actually designing in a smarter way. So we need to use less and consume less to live our lives.
And what innovations are you seeing that enable sustainability?
I think that in the past few years, there's been definitely a much better and more spread out understanding of building science. More and more builders and architects and consultants are trying to really see the science behind building and understanding exactly how a building breathes, the importance of understanding the indoor and outdoor humidity, indoor and outdoor temperature, and how these things relate to the life of a building. So a better understanding of building science means that we can apply that science to construction, therefore use materials that come out of this innovation, of this better understanding of how a building behaves. So there's new membranes, there are more advanced and long-lasting tapes that are all parts of a general movement towards making our buildings better. We understand that we spend a lot of time inside our buildings. We understand that quite often we are poisoned by our own buildings because of mold, because of a lot of issues because of carbon monoxide and a lot of other things that we generate because we create bad buildings. So luckily there is that understanding, and not everywhere necessarily, but a lot of people are actually trying to really build better buildings using this new technology, using this new knowledge that is available, and using all the new tools that we can find on the market.
When you think future about the built environment, what is it that excites you the most?
What excites me is, I think, this feeling of understanding that there is a better understanding of building science. There is a common desire of doing things better. And what really excites me is that I'm trying to be, and we are as an office trying to be part of that. We want to continue to push for better buildings. We want them to last longer. We want them to perform them better. And we want them to create environments that are comfortable, that are beautiful to look at, and that are long-lasting for the people that ask us to design those buildings. There's a lot of technological advancement. There are regulations that are pushing in these directions. And what we need is really a wider audience for these technologies and a larger mass production that can reduce the prices and the cost of the building materials and labor to actually achieve more high-performance buildings and better buildings for our environment.
Well, Alessandro, thank you for joining us, and we certainly look forward to continuing to see more of Demo Architect's wonderful sustainable designs.
Thank you very much for having me. Really appreciate the opportunity.
This podcast was brought to you by VinZero. VinZero help the AEC and manufacturing industries keep pace with digital change and achieve their technological and sustainability leadership goals. VinZero is a company that cares about creating and building a better world. Together, we are working with industry and environmental experts, providing forums and platforms through our VinZero Think community to create conversations that matter to our future generations. We invite you to join in the conversation and participate in our Think community. Like and subscribe to Think Future to stay up to date with the latest innovations and conversations as we take AEC and manufacturing around the world closer to zero. You can download our podcasts at vinzero.com or from your favourite podcast platform. From VinZero Think Future, thanks for listening.